Hello, ladies and gentlemen, and welcome to Lesson 30 today. And our goal is to divide decimal dividends by decimal dividers. When you think of that, it's like, whoa, that seems a little complicated. I don't quite remember what these dividends and divisors are. Don't worry, I don't want you to get stressed out yet. Well, actually, don't get stressed out at all because this lesson is actually going to be much more uh, I don't know, stress relieving than you might think. You're going to say after this lesson, whew, I feel really comfortable. This isn't as bad as I thought. Right? I want you to keep that in mind. And if you do have some trouble with this at the end of the video, go to the we do portion, our smaller group where I break it down a little bit more and we'll do several more problems. All right? So let's get started. To start, I'd like each of you to go to page 136, which is our lesson 30 problem set. But I'm actually going to focus on the left-hand side, that blank page. And if you don't have your workbook, as always, go ahead and use a scratch piece of paper, that whiteboard. But if you do have that scratch paper, it'd be really nice to keep it in handy because the next couple lessons have similar ideas and concepts, so you can use it as a resource. But anyways, let's get started. The first problem here, we have 9.0 or 9 wholes divided by 1/10. This almost seems a little bit of a review from last week. There's a few ways we can do it. We can draw 9 models. And that is certainly an acceptable way. Now, when you start getting some larger numbers, it becomes a little bit more difficult to find the space for 9 models. And we know that we would actually be dividing it by 0.1, or which we know is really 1/10, and it looks like this as a decimal or as a fraction. So we would really have to then decompose this one into 10 parts, 10 parts, 10 parts, 10 parts, each of these out of 10 parts. And we certainly know, as great mathematicians, we would label this one whole, and one of those little lines we'd label 1/10. So how many pieces do you have all together in this here? How many tenths? Right, well, you really have 90. If you counted them all up, 10, 20, 30, 40, 50, 60, 70, 80, 90. Right? There's one way that this can be solved. Right? A couple geniuses, including, I believe, Mr. Potter for his exit ticket review from last week, he decided to do fractions and said, well, here's one whole, and then we need 2 wholes and 3 wholes, and there's our 4th and our 5th and our 6th, both equaling a whole. We need our 7th, our 8th, and our 9th whole. And how many do you have altogether? How many tenths? Right, well, again, you have 90 of them. Right? Maybe a little bit shorter of a way to solve this problem compared to drawing models. Now, the third way, which we are going to be focusing on today, is actually, let's show this as division. I'm going to show this as 9.0, 9 wholes, divided by 0.1 or 1/10. Mr. Philip, I don't know how to do this with decimals. You're right. Wouldn't it be nice just to get rid of the decimals altogether? We've done that before. Yeah, let's do that. So what I'm going to do is that I'm going to get rid of the decimal. Well, I don't like that there. So in order to get the decimal and move it over, okay, maybe I wanted to get a little larger, I'm going to do it by 10. And anytime you have this fraction, which this line means division in the fraction, if you do it to the denominator, you have to do it to the numerator. So I have to multiply this one by 10. What's 9 times 10? 90. What's 0.1 divided by 10? Well, or divided by, I mean multiplied by 10. Well, you're getting rid of the decimal. It's going to be 1. And if you're not sure, you can put that on a place value chart. Right? You can certainly sketch that out real quick if you wanted and put in your tenths, your hundredths and your thousandths, and get a different color here for your decimal point. And then you'd go ahead and put in your 1/10. You're multiplying it by 10, getting larger. It's going to be in the one hole. What's 90 divided by 1? You can write it over. 90 divided by 1. Well, 90. There's your answer. A little bit shorter of a way to show your work, okay? But we all came up with the same answer, no matter which strategy you used. We're going to focus on this one today. Right? So sticking with that left-hand side of your workbook or that scratch paper, let's do another one before getting into the problem set. Right? But this time, oh no, it's not in tenths. Well, technically it is in tenths, but it's not just 1/10, it's 5/10. It's okay. Don't worry. Let's take our 3 and 5/10. We're going to divide it by 5/10. We're turning this equation into almost a fraction. Remember, this line here means division. Now, certainly I don't like those decimal points there. So I want to get rid of it. I'm going to multiply by 10. I'm going to multiply this one by 10 because now I know that if I multiply the denominator, the numerator has to be multiplied the same. Again, we're basically are making equivalent fractions here. All right? And when I multiply, I know that this number is going to get bigger. It's going to be bigger than 3. It's really going to be 35. And I know that this is going to be bigger, so it is moving on the place value chart to the left just one place value, and that's going to give us 5. Now we have 35/5. I can turn that one into a division problem again. 35 divided by 5, and whoa, we have a basic math fact. Amazing. So, what's 35 divided by 5? And if you're not sure, right, make sure you get onto your reflex this week. Right? And there's your answer. Well, Mr. Philipp, you're not telling me the answer. It's a basic fact. We know it. Skip count if you need to. All right? Let's move on to the next one. I wonder if this one will give us some basic facts too. First off, let's rewrite this as a fraction. 2 and 1/10 divided by 7/10. I don't like that decimal there, so I know I can multiply it by 10, make an equivalent fraction here. And if I multiply this by 10, I have to multiply the top by 10. Getting larger by one place value is going to give us 21. And this one's going to give us 7. As I rewrite this, 21 divided by 7, oh, basic fact. Look at that. There's your answer. Right? This equation and this equation are equal. Right? So maybe I should tell you that this is going to be 3. This one is going to be 3. It seems strange. Okay? But if you had 2 wholes and 1/10, you divided it by 7/10, you're going to get 3 equal parts. And if you're wondering about how that truly works, I urge you to come to the we do part of the video where I'll break that down a little bit more in the picture form as well as this fraction form too. Okay? So let's do a couple more, then we'll get into that problem set. Still on that left-hand side of scratch paper, you can certainly pause the video at any point here and try to solve it on your own and then see your knowledge of this concept within only just a few problems. But again, first step, rewrite it as a fraction. I think I've mentioned many times, I prefer fractions over the decimals. It just seems to be easier for me personally. But anyways, now in order to get rid of this decimal, I'm going to multiply it by 10. So I need to multiply the top by 10. Getting bigger is going to be 36 divided by 6. Now if I rewrote this, 36 divided by 6, that gives us our basic fact. 6, so our equation, our answer is going to be 6. Again, if we had 3 holes and 6/10 in another hole, and we put them on groups of 6/10, you'd have 6 total groups or 6 parts. Again, this part, these two equations are equivalent. You're going to get the same answer. Let's see, do we have another one? Ah, our last one. Oh, this one doesn't look good. I notice that there's one place value in tenths, and this one is in hundredths. But don't worry, we can do the same thing. 4.2 or 4 and 2 tenths divided by 7 100ths. And as I mentioned, I like to work on this denominator first. In order to get the decimal out of here, I'm going to have to multiply it by 100. Or we could say 10 to the power of 2 means the same thing. All right, we're moving it 2 places on the place value chart. Draw that place value chart real quick for those who need to see it. Here's our hundredths and our thousandths. We have 7 in the hundredths. I need to get it over here. I need to move 1 place value, 2 place values. So I need to multiply it by 100. And if I'm multiplying the denominator by 100, I need to multiply the numerator by 100. So this one, as we just saw here, is going to give us 7. But what's this one up here? Right? Don't worry, you could put 4 and 2 tenths on here. Maybe we'll extend these lines a little bit here. And we're moving 2 place values. 4, 1, 2, be over here. And this one's 1, 2, be over here. So what's place value is that? Well, this is the ones. Here's the tenths. Here's the hundredths. Okay, so we would have 420. Right? And now we can rewrite this 420 divided by 7. Okay, almost a basic fact, isn't it? Really, we could break this up into 42 times 10. Right? Divided by 7, or you simply could do 420 divided by 7. And I think that tends to be pretty common for most of us. How many 7s go into 4? None. I didn't use any. I'm going to bring down the 2. How many 7s go into 42? Well, 6 of them. I know those from my basic facts. 7 times 6 is 42. I used all of them. I find the difference. Bring down the 0. Now, don't forget that there's that extra 0. I don't want you to think, oh, the answer is 6. Because now we still have to do the ones place. How many 7s go into 0? 0 of them. I didn't use any because there isn't any left. And we're left with 0. Now we can stop before the decimal. So our answer, you're going to have 60 pieces or 60 total parts that are broken up into 7 100ths. All right. If that seems to be confusing, again, reach out to me as a private comment or a class comment to your peers, or really check out the We Do video. All right. So as we wrap up, we have just another minute or two. Right, we can certainly move on to that problem set, 136. Right. Now, I wanted to do those extras because these problems are actually very similar. Right. If we have 3 and 5 tenths, we're going to divide it by 5 tenths. Over here, we still have 3 and 5 tenths, but we're dividing it by 5 100ths. Very similar, except for the fact that in order to get this out, we have to multiply by 10. So there's equivalent fraction here. Over here, in order to get it, I need to move this decimal 2 places. Really, I'm multiplying this one by 100. I need to multiply this one by 100. And that's going to give us an equivalent fraction. Okay. Similar, but the place values change the answer to the work by 10, really. So here we're going to have, all right, a little technical difficulty, but I think we can squeeze this in here. Okay, I apologize if there's a little disjointedness on the video. 3 and 5 tenths times 10, it's going to give us 35. And we have 5. Again, we have a nice little work here giving us 7 parts. Oh, I should really write this as 35 divided by 5. It's going to give us 7. Over here,